Hello students, welcome to the Artificial Neural Network practical series. In this practical, we will design a simple linear neural network model. As we all know, the basic neural network model consists of input and the output layers. In this diagram we have a input layers. This is my input layer and this is your output layer. In input layer we have a two nodes x1 and x2. These are called as input nodes. These nodes are used to receive the input x1 and x2 from the other neuron or from the external environment. There is a connection between input and output node. The x1 has a connection with y, that is your output neuron, and x2 also has a connection with y. Each connection in ANN, each connection is represented by a weight. Here we are using a weight as W1 and W2. So this is the basic linear neural network having input layer and output layer. Within input layer we have a two input nodes, and within output layer we have a single output neuron. You can see here the above diagram represents the simple neural network having one input and one output layer. There are two neurons at the input layer and one neuron at the output layer. Now the neurons are connected. The neurons are connected with the weight. Nodes are connected with the weights. We are not consider the bias here. The concept of bias we will see in the next video. Here we only consider the input and the output nodes. X1 and X2 are represented the input to the neuron x1 and x2, and y is represented the output neuron, and W1 is the weight of x1 and W2 is the weight of x2. In this case we will first find out the net input to this neuron. First we will calculate the net input of the input neuron. So now this is the formula y in is called as net input. Net input is given as y in equals to x1 w1 plus x2 w2. This is the formula to calculate the net input in the neural network. Now after calculating the net input, we will generate the output from the neural network. To generate the output from the neural network, we will apply the activation function on the neural network. So in this case we are using a binary activation function. The binary activation function has two possible values, either 0 or 1. Now these two values are based on some condition. If the net input is less than or equals to 0, in this case 0 is your threshold value of the neural network. This is your threshold value. That means y in is less than or equals to threshold, that is your 0. In that case the answer will be the 0. The output of the neural network will be the 0. If y in is greater than 0, in this case the output is 1. That means binary activation function only generates two output value, either 0 or 1. Now we will see this neural network in the Python. So now we will switch to the PyCharm. This is your PyCharm. This is the IDE which is used for writing a Python code. Now we will type a Python code to implement the linear neural network. Now first we will create a, in this case first we will create a, so to create a project, go to the file, new project. Now this is your location, and at the end we will give a name of your project. You can change your location of the project by clicking on this browse button. There is a directories, C drive, D drive. So I am storing this data in E drive. In E drive you have a YouTube data. Now, in this we will create a project folder ANN practicals. Okay, now see we have a ANN practicals and click on OK. Now, this is my path to store my practical. Now create, just click on create. It is asking whether to open this new project in this window, that means in the same window, or you want to create this project in the separate window, name window. Then select this window. It will replace the window with the R project. Now it is creating a virtual environment for us. Just wait for some time. It will just store all the libraries, default libraries that are required. Now we can see by default it creates a file main.py. This is the by default file, right? Now we will create a file to write a code. Just right click on your project, new Python file. Now enter the name for the practical. Now I am typing practical 1A and OK. In this practical we have two inputs, x1 and x2. Now first of all we will take the input from the user. For that I am writing a message, print, enter the input node x1. Now we will take input x1 equals to, we can typecast it into float so that we can store the point values also. Now in Python we have an input function to take the input from the user. Now same, we will take 2 second, enter the input node x2. Now store it in x2. Again typecast it in float so that we can enter a point values input. Now each input is associated or is connected with the output via the weight. So the next step we will take the weight from the user. Enter the weight that is W1. Again W1 equals to float input. Then for second weight enter the weight W2. Now W2 equals to float input. So now input and weights are ready. User will enter the input x1 and x2 and then W1 and W2. Now we will calculate y in. To calculate y in we have a formula, x1 W1 plus x2 x1 into W1 plus x2 into W2. Now this is my net input, that is your y in. Now we will apply the activation function on it. If binary activation function y in is greater than y in is less than equals to 0, in this case the output y output, only write output, the output of the neural network is your 0, and else the output of the neural network will be 1. Now we will print all the thing. First we will print all input input nodes. Input nodes are x1 comma x2. Then print weights again comma w1 comma w2, and then next is your net input y in comma y in, and last we will print output, that is your y. So now this is your simple program which shows the basic linear neural network. Here we have a 2 input node, 2 weights, then y in, net input, activation function, and then all display all the inputs and weights, net input and output. Now we will execute this program. Just right click on this window, run practical number 1. It will ask enter the input node. So I am entering 0.2 and 0.6. Then weights 0.3 and 0.5. See, so these are the inputs 0.2, 0.6, weights 0.30, net input. Net input is calculated using this formula. We have a formula. Using this formula, the net input is your 0.36. Since this 0.36 is greater than 0, therefore the output of the neuron is 1. Now this is your simple practical. In this we study that there is a simple neural network and we apply the activation function on it and we get the output of the neural network. I hope you understood this session. Thank you so much.